Hello and welcome back. In the last two videos, we talked about how expressions, values, and how exponents work. Today we are going one level deeper into numbers themselves. We are going to talk about divisibility, factors, and prime numbers. This might sound like basic school math, but at the end of this video, you will see why prime numbers are literally the foundation of modern cryptography, including zero-knowledge proofs. So let's get started. What does divisibility mean? Let's start simple. We say that a number A is divisible by a number B if, when you divide A by B, you get a whole number with no remainder. For example, 12 divided by 4 equals 3. No remainder, clean. So we say 12 is divisible by 4. 12 divided by 3 equals 4. Again, no remainder. So 12 is also divisible by 3. But 13 divided by 4 equals 3 with a remainder of 1. It does not divide cleanly. So 13 is not divisible by 4. When we want to write this in math notation, we use a vertical bar symbol. We write 4 vertical bar 12, and we read this as 4 divides 12. And when a number does not divide cleanly, we put a slash through the vertical bar, and we read it as 4 does not divide 13. When B divides A cleanly, we call B a factor of A. So 4 is a factor of 12. 3 is a factor of 12. 6 is also a factor of 12. What are prime numbers? A prime number is a number that has exactly two factors, 1 and itself. Let's check a few examples. The number 7, its only factors are 1 and 7. Exactly two factors. So 7 is prime. The number 2, factors are 1 and 2. Exactly two factors. 2 is prime. And it is the only even prime number that exists. The number 6, its factors are 1, 2, 3, and 6. That is 4 factors, not 2. So 6 is not prime. We call it composite. And the member 1, it only has one factor, which is itself. So 1 is neither prime nor composite. It is a special case. The first few prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. They go on forever. The fundamental theorem of arithmetic. Every whole number greater than 1 can be written as a product of prime numbers. And this can be done in exactly one way. This is called the fundamental theorem of arithmetic. Let me show you with an example. Let's take the number 60. 60 equals 2 times 30. 30 equals 2 times 15. 15 equals 3 times 5. So 60 equals 2 times 2 times 3 times 5. We can also write this as 2 squared times 3 times 5. No matter how you start breaking 60 apart, you always end up with those exact same prime pieces. The recipe is always unique. This is why primes are called the atoms of arithmetic. And this is also why we exclude 1 from being prime. If 1 were prime, the factorization would never be unique. Why primes matter for cryptography? Now let me show you why all of this matters for zero-knowledge proofs and cryptography. Imagine I give you the number 77 and I ask you, what are its prime factors? You might try, is it divisible by 2? No. By 3? No. By 5? No. By 7? Yes. 77 divided by 7 equals 11. And 11 is also prime. So 77 equals 7 times 11. That was not too hard. But now imagine a number with hundreds of digits. Finding its prime factors becomes essentially impossible. Even for the most powerful computers on Earth running for thousands of years. This difficulty is called the integer factorization problem. Multiplying 7 times 11 to get 77 takes one step, instant and easy. But going the other way is nearly impossible for huge numbers. This is called a one-way function. is in one direction nearly impossible to reverse, and this is the foundation of cryptographic security. The BN254. The curve that Circom uses by default is called BN254, and at the heart of this curve is a very large prime number, we call it P. You can see it on the screen. It is 254 bits long and it is prime. Every single calculation inside the Circom circuit, every signal, every constraint, every arithmetic operation, all of it happens inside this prime. Every value in your circuit is a number between 0 and p minus 1. The reason we use a prime for this is exactly what we learned today. Primes have unique mathematical properties that make the arithmetic inside circuits clean, predictable, and secure. In the next video, we will learn exactly what it means to do arithmetic inside a range like this. That is called modular arithmetic. So let's do a quick summary. A number is divisible by another if it divides with no remainder. Factors are numbers that divide a number cleanly. Prime numbers have exactly two factors, 1 and themselves. Every number greater than 1 breaks down into primes in exactly one unique way. And the difficulty of reversing the factorization is what makes cryptography possible. In the next video, we will talk about modular arithmetic, the clock math that every ZK system lives inside. See you there.